This is the chromatogram we will create. This software is not chromatography simulation software, or at least not the chromatography simulation software you have seen in the past. In this software, you place the peaks on the chromatogram where you want them. And in this software, you establish the relations the peaks have to each other. This is chromatogram creation software. I mention this up front as a way of an explanation, but you may not fully get until you have used the software and applied it to your use case. This is not about the theory of chromatography, but about the skill of chromatography, using chromatography to solve problems. So, as I said, this is the chromatogram we will create. Its purpose is to be used in class as a basis for an in-class discussion on chromatographic peak separation, peak resolution, and to demonstrate the utility of gradient elution. On the chromatogram are 9 peaks, including 3 peak pairs, which, in isocratic mode, don't have baseline resolution. As a way of learning how to use the software, we will go through the process of placing each peak on the chromatogram and defining the retention time, peak shape, peak height, and peak width. We will also improve the separation by using gradient elution to achieve baseline resolution for all of the peaks. The interface layout is broken into sections of similarly assigned buttons. The system buttons are in the upper left corner of the window. The exit button quits the program. The load and save buttons bring up the Windows File Manager, which displays the load or save dialog box. Below that are the buttons for creating a chromatographic peak. Continuing down the column is the isocratic gradient selection, and at the bottom of the column is the student testing section. Once a peak is created and moved to the chromatogram, the buttons on the right side of the interface are turned on. These buttons are used for manipulating the chromatographic peaks. At the top, right is the input section for modifying the peak parameters: retention time, peak height, and peak width. Below that is the button to assign those parameters to the selected peak. Continuing down the column is the list of peaks on the chromatogram. And directly below that is a button to allow a name to be assigned to the selected peak. Next are the buttons to delete a single peak, delete all peaks in the chromatogram, redrawing the chromatogram, and assigning a baseline offset for the chromatogram. Next is the spreadsheet button, which brings up a spreadsheet of the peaks in the chromatogram for convenient manipulation of the chromatogram. And last is a checkbox to toggle chromatogram chart annotations. The process of building a chromatogram is first creating a peak on the left side of the interface, then transferring that peak to the chromatogram for further manipulation by the operators on the right side of the interface. We start by creating a peak. Click the Create Peak button. We start with the peak shape. The front of the peak and the tail of the peak are both the same shape, creating a Gaussian peak. The default Gaussian peak is not a typical chromatographic peak. The peak shape buttons allow you to change the front and tail of the peak separately to create the peak shape you want. Peak shape is central to your chromatography because, as you know, peak shape can tell you everything you need to know about your sample and the operating condition of your HPLC column, solvents, and pumps. But those are topics to be covered later. Let's change the front of the peak. Change the front of the peak from a 5 to a 1, and click Create Peak again. This creates a peak with a steeper slope on the peak front. This is closer in shape to a chromatographic peak. We can also change the peak tail to something broader. Change the tail of the peak from a 5 to a 10 and click Create Peak again. This creates a peak with a more sloping tail. Let's use this peak shape for our chromatogram. Next, before moving the peak to the chromatogram, we have to set the retention time. In the box below, with the seconds heading, change the retention time from 300 to 60 seconds. Now that the peak has been defined, we can move it to the chromatogram. Click Move Peak. Once the peak has been moved to the chromatogram, the peak can be updated when necessary. Click on the peak name in the list box. The peak will be highlighted on the chromatogram, and the parameters associated with that peak will appear in the master section of the chromatogram manipulation panel. As an example, let's change the height and width of this peak. Let's change the height to 80 and the width to 30. Click on Update Peak to assign the new updated parameters to the peak. Let's go back to the left side and create another peak. Click on Create Peak. We create a peak with the same shape as the first peak, but let's change the retention time to 90 seconds, and move the peak to the chromatogram by clicking Move Peak. Let's change the parameters of the newly created peak. Select the peak's name, and the peak will be highlighted on the chromatogram. The peak's retention time, height, and width will be inserted into the appropriate boxes. This time, let's change the height and the width to 25. Click Update Peak. Let's create a third peak. So, on the left-hand side, click Create Peak to create a peak with the same shape as the previous two peaks. Let's change the retention time to 170. Click Move Peak. Let's change the parameters of the third peak by selecting its name in the list box and change its height to 80 and its width to 30. Click Update Peak. Peak names can be changed by clicking on the peak name in the name list box. This highlights the peak on the chromatogram. Go to the entry box and highlight the entire name. Type in the new name and click Rename Peak. We can name the peaks benzene, toluene, and orthoxylene. There are no restrictions or requirements for naming peaks. We have placed 3 peaks on the chromatogram the long way. This process is good for experimentation, maybe as a starting point, when you're not sure what you want, but as you gain experience, you will probably have a definite chromatogram in mind when you start to use the program. This is where the spreadsheet comes into play. You can use the spreadsheet function to easily add or modify multiple peaks. Let's open the spreadsheet. Click on the Spreadsheet button. I'm going to add 6 new peaks by clicking on the Add button 6 times. In adding new peaks, the software takes into account the peaks already on the chromatogram and tries to place the new peaks so that they are separate from but similar in size and shape to the peaks currently on the chromatogram. This is done just to make things easier. In addition to adding and deleting peaks, the spreadsheet functionality allows for modification of all peak parameters from name to peak width. If you remember back to the original chromatogram, we had already decided what we wanted the chromatogram to look like, so let's enter the parameters that will get us close to that chromatogram. Movement in the spreadsheet is standard. Click in a cell to highlight and change the contents or use the arrow and tab keys to move from cell to cell. Let's finish entering the peak information. We're building a chromatogram of hydrocarbons. From our fundamental knowledge of hydrocarbon chemistry and our understanding of HPLC separation mechanics, we have an understanding of the order in which the hydrocarbons would elute from a reversed phase column. So knowledge of chromatographic theory is assumed as a basis for using this software. This software is a tool to establish a foundation for teaching the skill of chromatography. Once you're done, click Spreadsheet. If there are changes, you are asked if you want to keep the changes. The chromatogram isn't quite the chromatogram we want. The tails of the peaks are too skewed. This chromatogram appears like one resulting from either an old, worn column or an HPLC with a pump problem, or maybe both. Regardless, let's go back and make some changes. Click on Spreadsheet to open the spreadsheet again. Let's sharpen the peak tails by changing them all except the last two from 10 to 6. The last two are further out on the chromatogram, and one would expect their fronts and tail to be a bit less sharp. So let's change benzoapyrene from 110 to 3.8 and chrysene from 110 to 3.6. Click Spreadsheet. The chromatogram now looks like good chromatography. Other features of the spreadsheet include using the column headings to reorder the peaks. We entered the peaks slightly out of retention order. Let's reorder them from the shortest to longest retention time. Just click the retention time column heading. Each column heading acts in a similar way. The list order changes in both the spreadsheet and the peak list. As we stated at the beginning of this video, we wanted to use this chromatogram as an in-class aid when discussing peak resolution and gradient elution. We have a chromatogram with 3 peak pairs of peaks that in isocratic mode do not have baseline resolution. If we want to do quantitation, it is better to have baseline resolution between all peaks. Let's try gradient elution. Click on the Gradient Radio button. This turns on the gradient elution functionality. Change the starting gradient ratio to be 20% B. Click Gradient. The result is the result of using a 20% to 50% gradient elution. With that, we can achieve baseline separation. And we can also shorten the analysis time by raising the N%B gradient elution ratio to 70%. Of course, we can continue to manipulate the gradient elution parameters to demonstrate various chromatographic topics. And finally, to delete peaks, you have 2 options. Choose a peak from the list box and click on the Delete Peak box. Answer yes, and the peak is deleted. Another option is to delete peaks using the spreadsheet interface. Click Spreadsheet. Highlight a peak by choosing the row. Click Delete Peak, answer yes, click Spreadsheet to get back to the default interface. There is also an annotation function. It's not elaborate, but it's effective. It's the checkboxes at the lower right of the interface. Click on Names and redisplay the chromatogram. As I said, it's not elaborate, but it's effective. Turn off the annotation by unchecking the boxes and redrawing the chromatogram. Thank you for watching this how-to video. Should you have any comments, you may submit them to this address. Thanks again.